Welcome to this lecture. In this, we'll solve a numerical related to the transfer function of a system. This question is from GATE question paper of chemical engineering, GATE chemical engineering question paper. Well, if you know the concept of, it's a simple problem. The problem is this. If you know the concept of transfer function, laplace transform, and the deviation variables, this question is very easy to solve. If you see the other way, for a student who has just learned what a transfer function is, for him, this question will help him understand the concept of transfer function, the concept of deviation variables, and the application of Laplace transform. So either way, so this question is a very good question that was asked in the GATE examination. Simple problem illustrating the concepts. So let us go into the problem. Meanwhile, I'll request you all to kindly subscribe to this channel. If you like this channel, please give a like, give your comments, and also share it to your friends. Only if more and more people, if more people respond to this lecture, then that will be a motive for me to come with more such information, and more such problems. So please subscribe to this channel. Go to the channel button and hit the subscribe button and share it to your friends. Now, coming to the problem, the problem is this. This is from 2001 chemical engineering paper. The process is initially at steady state with its output y equal to 1 for an input u equal to 1. This is u. The input is suddenly changed to 2 at time t equal to 0. The output response is this 1 plus 2t. The transfer function of the process is 4 options are given. So you have to find the transfer function and choose the correct option for the answer. Well, the steady state variables are given as output y equal to 1, this one, and input u equal to 1. So I have denoted them with a subscript s, which we use for steady state variables. So us equal to 1 and ys also equal to 1. Now, what is the input? The input is suddenly changed to 2. It says here the input is suddenly changed to 2 at time t equal to 0, right? It says here the input is suddenly changed to 2. From what? From where? What level? Input is initially 1. From 1 there is a sudden change to 2. So what sort of an input is this? It's a step input, right? From 1 there's a sudden change to 2. So input this symbol is given as u. So if you use a capital U deviation variable, that is u minus us equal to m into ut. What is the magnitude of m? Magnitude of m, it changes from 1 to 2, right? So the inputs is suddenly changed to 2 at time t equal to 0. From 1 it changes to 2. So what sort of input is this? So this is a step input of magnitude m. What is m here? M is 2 minus 1, 1. So m is 2 minus 1 equal to 1. Well, there may be small confusion here. The u is used at two places. Here the input variable is shown as small u. So this u represents the input variable. Okay. Whereas this u represents step function, unit step function. This represents step function, this u. So let there not be any confusion between these two, because the input itself is given as variable u. So this is the input variable u, and this is step input u. This is step input u. This is step input of magnitude 1. So now transfer function is what? Ys by xs. X is okay, in input output. Y is output. Let's see what is output. Output is given here as this, yt equal to 1 plus 2t. So output is given as yt. This is y for y bracket t. What is given as yt equal to 1 plus 2t. This is what is given output. Output 1 plus 2t. Now let us find the Laplace transform of these two. Input u of t. What is the Laplace transform of this? U of s equal to, what is u of t? U of t means what? Nothing but 1, right? So transform of that is 1 by s. So that is the Laplace transform of u by s, u of s, input. This is input. Now output, what will be y of s? Shall we take directly y of s here? This is the output variable. This is not the deviation variable. Sorry, this is not the deviation variable. So you have to find the deviation variable. That is important here. So we cannot take directly y of s here. So capital Y t equal to this y of small y of t, what is given, minus ys. What is y of t given? 1 plus 2t. What is ys? Ys is given here as, ys is given here as 1. So 1. So this is equal to simply 2t. So capital Ys, capital Yt, the deviation variable, output deviation variable is simply 2t, right? Now you find y of s. Y of s equal to what? 2t. Transform of t is 1 by t. T is what? 1 by s square. So y of s is 2 by s square. So now you can find the transfer function. So what is the transfer function? The Laplace transform of output deviation variable, that is y of s, by Laplace transform of input deviation variable u of s. So y of s is 2 by s square and u of s is 1 by s. So what is the answer? 2 by s. So transfer function is 2 by s. The right answer is 2 by s. Is there an option for 2 by s? Yes, option A. Option A is the correct answer, 2 by s. So this is option A. Is the right answer. So this problem tells us what is the, how do you find the transfer function? Transfer function is Laplace transform of output deviation variable by input deviation variable. So it is very important to consider the deviation variable and not just the actual variable. Suppose if I had taken y of s at this step itself, if I had found y of s here itself without considering this deviation, then you would have got a different answer, wrong answer, and for that also there is an option. For that wrong answer also there will be an option, so which means you will be losing marks or you will be getting negative marks. So you have to understand the concept of deviation variable. This is the actual output variable. This is actual output variable. So you have to consider the deviation variable. This is the deviation variable. Yt minus ys. Yt is given the output variable, actual output variable. Steady state variable also is given as 1. Steady state output variable is given as 1. So the deviation variable is not 1 plus 2t, it is 1 plus 2t minus 1, that is 2t. So it helps you understand the concept of deviation variable, the concept of taking Laplace transform, and the process of finding the transfer function. So a simple problem helps you understand all these important concepts. I hope you have understood this. We'll come with more such information and more such problems. We'll be solving more such problems. So please stand in for my next session. See you in the next session. Bye.